All right. Well, good morning. Good morning. Thank you all for coming to this session. I really appreciate it. And I know we're the only thing between you and the lunch, so I'll make sure I don't run over. Now, before I begin, how many people actually know about containers and Docker? Yeah, everyone who are using it? All right, very cool. And the topic today is Kubernetes. How many people have heard about Kubernetes? Yes, everyone. All right. And how many people are using it? Oh. But I ask this question everywhere I go, but that's okay. But more importantly, how many people have actually tried or seen it in action? Anyone? Okay. Okay. Good. So some of these things I'm gonna show you today will be new to you. So that's a good thing. So my name is Ray. I'm a developer advocate for the Google Cloud Platform, and part of my job is to actually bring some of the latest and greatest technology that Google has to offer to developers like you. And the other side of it is that I like to hear about your experiences and your feedback and how you are using technology today. So please feel free to contact me at my Twitter at Satanism. And that is my profile picture. I'm probably the only speaker who doesn't show his face or her face. I always have a camera in front of my face. It's kind of funny because every organizer doesn't recognize me anywhere I go. It's like, hey, who is this guy? But the reason I'm doing this because I'm kind of shy naturally, and some days I don't feel so good, like today. I can actually get somebody else to come up here and not get killed. Okay. Whoa. Yeah. Okay. Well. So as long as it doesn't fall in the water in the Raspberry Pi, I'm okay. And aside from technology, I love to travel. That is me traveling, backpacking in Asia. This is in northern China, somewhere in the middle of the desert. And somebody told me I was a cheap backpacker, so somebody told me I can actually stay in an oasis in the middle of the desert for free. But the only catch is you actually have to go in a southwestern direction, and you have to walk there by yourself for about 4 hours. Anyone walk in the desert before? No? Yeah, some has. Yeah, some have. It's not easy. It's very, very difficult to do. And when somebody tells you to walk southwest in the desert for 4 hours, you walk that direction. You don't go around anything. If there's like anything in the middle of it, like a big sand dune, you don't care. You just go up and you come down. Otherwise, you might just miss it in 4 hours. But anyways, if you'd like to see any of my photos, go ahead and check out my Flickr under the username Satanism as well. Cool. So I think everybody probably have heard about microservices already. I know there are university sessions. There are many sessions about it. Some of them are theoretical, right? They teach you about why you should be doing it, why you shouldn't be doing it. That is not the session here today. What I'm going to talk about is really just show and tell what it may feel like when you have a microservices-based deployment. Okay. So I'm going to demonstrate this more or less with some live coding and the best guestbook application that you'll ever see. I'm not a front-end developer. This is the best thing I can do. And it's really easy. I mean, you have your name and message, you click on something, and then it saves it to a database. And but it also has a hello world built in it. So it's kind of like the best of the both worlds. And this is like the very high-level architecture. Everybody probably seen it before. There's a front end, and then there are services that you call. And then some of the services may be triggering and saving data into a database like MySQL. And I'm also doing some session replications with Redis as well. So that's the ultimate thing I want to demo today. And then the ultimate thing I want to demo is actually one of these. So that will be very exciting towards the end. Okay, so I'm going to jump through many of these things very quickly, but I just want to catch up with the state of how we deploy applications today. Right, in the traditional Java applications, we create year files and word files. You package everything up. Those services is probably a jar file. You modularize it, but you package it in the same deployable, the same deployable, right? But then what do you do with these files? Well, most of the time you have to deploy it into an application server. But how do you actually do that? Well, first you have to provision like a machine for it. You have to lay down the operating system. You have to install a bunch of packages that your application or the operating system depends on. And then you have to install the application server that you want to run. And then you have to configure it, and you have to secure it. and then the list kind of goes on. I remember in my consulting days, I actually have to tell the line of business like how many servers I need before the project even starts. And because it takes a long time to get the servers provisioned, right? For me, my experiences has been 9 months. Like it takes about 9 months for me to get the servers I need for all the environments. Anybody do better than half a year, 6 months? Yeah, some do. Yeah, one month. No. Yeah. Wow, that's really cool. Yeah. So a lot of people don't get that opportunity, however. So and when you install some of these things, in my past experiences, there are these run books, right? There are these instructions what you have in the documentation somewhere, right? Maybe some developer and some ops, we write it together, and it's line-by-line instructions on what operating system we need to install, what packages do we need on these machines, what versions of Java do I need, and what versions of Tomcat, Wildfly, or whatever, Glassfish that I need to run this, and configure the GIND and I don't know, JDBC, pooling, and a bunch of things. And then you deploy it, and you find out nothing works. And not only that, because it's a manual process in most cases, and in some cases you have some kind of tooling to help you, but still you have to go to this machine by machine. And then you run into some of the issues of, well, actually, let me ask a different question. How many people have issues where it doesn't work in production, but it works everywhere else? Anyone? Yeah, most likely there's a configuration problem somewhere along the line that was just misconfigured, and you just don't know what happened. It's the environment that's constantly changing, and you just don't have a really good control over it. Okay. So let's see how microservices are different in a way. So I'm just gonna jump straight into the code. Now, I hope I still have my internet connection. So I'm gonna do a Docker PS. Okay, very good. I have internet. Okay, so in microservices, you might be using some frameworks, right? How many people heard about Spring Boot? Yeah, all right. So that's what I'm going to do very quickly in the next couple of minutes. And there are many other frameworks, right? There's Spark Java, there's Vertex, and Wildfly has Wildfly Swarm. So you can actually use these frameworks to build your microservices very easily and quickly. And they all have one thing in common, which is that they embed the server components directly into your jar file, right? So I think most people have seen it already, but let me just run through a very quick example of this. I'm gonna do a hello world Groovy file, and just to kind of show how easy it is to write a service. And you're going to learn, I think Josh has a session later today, so you're gonna learn a lot more about this from Josh. I'm just a lowly user here, trying to learn what Josh is doing now. So here I'm gonna do a class hello world, and then I'm going to define a function, and I'm gonna call it multiply, and I'm going to take in int, two of them, and then I need to respond like a JSON payload, right? So I'm gonna do x is x and y is y, and the result is x times y. That's very easy to do. And then this type of framework, what you can do very easily is just to kind of annotate your way to expose the service as well. So I can do something like request mapping, and I'm going to call it multiply, and then I'm going to take in the parameters directly from path. Okay, and then I need to do a path variable and path variable. I think that's it, and that should, if I run this, that should give me like a RESTful service that returns how to multiply two numbers. So the way I'm going to run it is just by using, because I'm using Spring Boot, all I have to do is do Spring run. And behind the scenes it's going to start Tomcat for me. And oh, that was super quick, like 3-4 seconds or so. If I'm really lucky today, I don't know if I am, I should be able to come to this URL. Yeah, give me two numbers, I don't know. What's the date today? February, so 2/10. Yes, all right. So that just returns the RESTful result, right? And I can do whatever here. Oh wait, what the? 34? Wait, what just happened? Anyways, that worked once, but not quite sure what happened. The trading stash. Oh, very good. Nope. Nice try. All right. Suppose that worked, which it does. Then what do you do? Well, you can simply put this into a jar file. So I'm going to do a app.jar. Right, you can do this with many different frameworks, and then you can Java jar and just run it this way, which is nice. And now you just have this one single component that you have to copy to different machines and deploy it, and you don't have to worry about a lot of the things because all you really need is the JVM, right? Just have the right JVM version, then you are set. Oh, I know why. Yeah, sorry. No, yeah. So here's an interesting thing. I was actually running something else on the same port, on port 8080. So, and that's one of the things that you're going to notice is that with these kind of services, you have to actually deploy many instances of it, right? Suppose you go back to that guestbook application example. I have the front end, you need multiple instances of that. I have the services, each one individually is like a standalone service. You don't just run one instance of that, right? You run multiple instances of it. And if you multiply it, if you run 3 instances each, you're looking at 10 different things you have to manage. And do you actually run those things on different machines, or can you actually bin packet together into fewer machines, right? And if you do bin packet together, if you run multiple processes together, then you run into the issue I just ran into, which is port conflicts, right? And you cannot have the same process, 2 different processes using the same port. So that's exactly what happened to me, and that was bad. And now that actually works out pretty well, okay? And then what do you do? Well, now you gotta deploy it. Now again, traditionally, the way you deploy this application is by understanding which machines you have in what environment, and then you go to that machine and say, okay, copy to here, start it. You have to take care of the startup scripts and all that stuff, and then make sure that the application restarts. What happens when one of these instances die, right? You have to monitor it, and you have to restart it automatically if something happens to it. And what if you have to scale it? You have to get more machines. You have to, do the installation process again. Well, how does that look like in a potentially a microservices world where you can actually manage many of these things with containers, right? And one of the things, so many people use Docker here already, so I'm not gonna jump into a lot of details here. But just so you know, right? I mean, you can just write a Docker file with all the instructions that you ever need to configure your image. And this image is basically the environment that you want, right? So you can install the right version of everything of your, you can select your operating system base image if you want to. You can select the JVM. You can apt-get install anything you want with a specific version. And this final image is actually this big binary where it not only have your application, but also all of the dependencies for that runtime environment. And that kind of gets us to a state where you have this single image where you can actually run anywhere. And you can actually get to that state in a way, right? Because when you do it with Java, you just need to make sure there's JVM, but you still have to worry about the operating system and all that stuff. With the image, with the container image, all of those things are encapsulated for you. So you can do something like this, entry point, and you can do like java-jar and then app.jar. And that should just build this image for me with my application inside and start it. And there are many different ways of doing this. So this is just using Spring Boot with Groovy straight up. As you can see, there's like no Maven file. There's no Gradle. There's like nothing in here. But I'm sure, how many people use Maven? Yeah, all right, very cool. Gradle, okay. And yeah, I still use and. Make. Wow, I'm kind of surprised, but many of my colleagues uses they use Make as well. So if you do use Maven, I want to show you something pretty cool. OPT2, I think. So here's a Maven project, and Spotify, who I understand is actually here today, and I know they had some sessions. They are very nice in terms of releasing some of these things as open source. So I actually found that this is actually one of the best and the first Maven plugin that I found that actually can create a Docker image for you directly from Maven pom.xml. And all you have to do is to include it. And rather than writing a Docker file, if you don't want to deal with that, you can just use like the base image. You can define the base image directly in the Maven pom.xml. You can give it an image name, specify how to start your application, and copy the right resources into your container. It's fantastic. But the thing I like the most is that it can actually tie in, of course, as a plugin. It can tie in into your entire build cycle, right? So you can tie in into the Maven build phases, and you can say, whenever I'm doing a package, go ahead and build the container for me, and tag the container the right way. So it's really, really easy to use. My favorite method, however, is, let me do this hello live. My favorite method is to use this file. So I'm gonna copy something here. Hello world service Docker file. Okay. LSD, interesting. That's not what I meant. Yeah, so this is the Docker file that I have, and as you can see, there's only one line. That's amazing. But what's happening behind the scenes is that this image I'm inheriting from behind the scenes is actually using a very special construct called unbuild. Okay, it's a special Docker construct. Anyone heard about unbuild before? Yeah, some have, but very few. And it's a really, really nice construct. So what I can show you is, for example, the actual base image looks like this, which has all the instructions that you need for me, to install the specific version of Groovy and Spring and all of that. And then at the build time, whenever there's a sub image that's being built based on this image, at the build time of that, I can actually copy just the source code, and as part of the image build process, I can actually build the application. Okay, and this is really nice for me because all I have to do is to send the source code across to the Docker context, and then they can, within that context, it will have everything pre-installed with the right build tools and environment, and then I can just build my application. And that application ends up in that Docker container as well. So it's a single one-shot process. So let me show you how that's done. So I'm gonna go ahead and say docker build -t hello world and dot, and that's pretty much it. Okay, so what's happening behind the scenes is it just sent the .groovy file and just built it within the container context, and then done with the build, and then I can actually just run it. Run p8080 and hello world. Oh, let me do -ti and --rm. That's pretty important because if you don't have --rm, your container is going to be persisted. Actually, even if you stop it, the image, whatever that you use, the layers are still there. And with the RM, it will just be transient. So once you're done with the container, it just removes the files as well. Okay. So that's pretty simple and easy. Let me jump straight into a few other things here. So when you're running some of these services, even within Docker, right, you still have some challenges you have to solve, right? Well, even without containers, the first thing that you want to avoid is port conflicts. That just happened to me. And how do you actually make sure that your services are up and running, right? What do you do with health checks? What do you do with readiness checks? What if something went wrong? How do you actually restart it? And there are a bunch of things that you have to be worried about. The more instances that you have, the more you have to worry about these things. And so I did the containers, and let me just go straight into why it does not matter with Google. All right, so let me do that. So why does it matter with Google? Well, because actually Google runs everything in containers. Everything at Google runs in containers. Anybody use the search, Gmail? YouTube, in case you're watching cat videos right now, please stop. But everything at Google runs in containers. In fact, we launch about 2 billion containers per week. And that's not European billion. I just learned the billion here could mean billion. In the States, it's just 1,000 billion, right? So 1,000 million, right? So there's a factor of difference here. But what I mean is 1,000 million containers, okay? And the way that we do it is that as an engineer within Google, rather than deploying to individual machines, like what many of the enterprises and projects may be doing today, we have so many machines. In a single cluster, we can have up to 10,000 machines, okay? So it's impossible for us to say which one of these machines to deploy to manually every single time at the scale that we need to deploy. So we actually just write a file, a configuration file, that specifies which cluster, and we call them cell, which cluster, which one of these 10,000 machine cluster do we deploy to? What application do we want to deploy? Some kind of arguments, to pass in at the command line. And then the requirements, like what is it that we need for the resource capacity that we need for this application. And we don't use virtual machines for these jobs. They're just containerized workload. We're not using Docker or anything. This is like proprietary stuff. But the underlying technology is actually the same. It's C group, which we actually contributed to the open source world back in, 2009 or so. Okay, so many of the container technology today is based on that contribution with the C group, which offers you the resource isolation. So we can specify how much RAM, how much disk, and how much CPU to use. And then, of course, how many instances do we need to run in our data centers. And of course, 5 is maybe too few for this extremely popular Hello world, so we can just change the number of instances to 10,000, and then we deploy it. And the way that we do it internally is that we have a tool called Borg, and basically the binary file, you send it through a central repository, and then you send the config file to the Borg master. And the Borg master is kind of like the server where it's managing all of the machines, and the Borg master is going to consult a scheduler to kind of figure out which one of these 10,000 machines that I have under my control can actually, is actually best suited to run this job, to run this workload. And then it's going to check the machines and say, okay, do you have enough capacity? Can you run this workload? Do you have the right resource configurations or whatever? And if it does, it's going to, that machine is going to pull down that binary image or the binary file and then run it in the machine. And it's going to do this very, very quickly to launch 10,000 instances across the cell, across 10,000 machines. And very soon, you're going to see the Hello World application that I wrote running in our Google data center in a way. And this can be done very, very quickly. There's a white paper on this. It's called there's a Borg white paper. And you can see a lot of these details as well. But it takes about 2.5 minutes for us to launch and start 10,000 of these instances across the machines that we have. So it's very, very quick. Okay. But that's kind of like, wow, that's kind of nice. That's really nice. In fact, that's how I felt when I finally see the oasis in the middle of the desert. This is about 2 hours into the hike, and when you look back, there's nothing. When you look front, there's nothing. And then another hour or so, you actually see the tree line that's ahead, and it's like, oh my goodness, I'm saved. I'm not going to die today. So what can we do? In the open source world, right? Because that technology is internal, right? People cannot get access to it except if you work at Google. But fortunately, right, we open source this project called Kubernetes, which is a container orchestrator. It's written in Go, not Java, but it's written in Go. But it's really nice. You can actually run this in different environments. You can run this in different cloud environments, and you can also run this on bare metal in your own data center. You can even run this on the Raspberry Pi here, which is really, really cool. And I'll show you how it works, but essentially, if you can target your deployment against Kubernetes, then you are kind of able to target against every environment that supports Kubernetes as well. So you can bring your application, these containerized workload, from provider to provider, or from your data center to cloud, or from cloud back to the data center. Like, it's really, really easy to do. And it's really, really a vibrant open source community. There are so many people who are contributing to it, and I think there are actually more people contributing to it outside of Google than Google ourselves. So, which is fantastic. That means that people really like to use it, and they're taking action to make sure that the project has some of the best features in the open source world. Okay. So how does that work? Well, in Kubernetes, you can go through a very, very similar process like our internal tool. Now, this is actually the open source tool, right? It's something that you can actually use today, Kubernetes, and this is how it works. So you will be able to build the container image, like what I have just done, and then push it to a central repository. That will be your image repository, whether it's Docker Hub or a private repository of some sort. And then you can define a config file as well that tells Kubernetes how to deploy and how to provision this application. You declare the state that you desire, and Kubernetes is going to be able to take care of that for you. And Kubernetes master will then check against the scheduler, again, very similar, and then check against every machine that's running the kubelet, which is like basically announcing itself to be managed by the Kubernetes master, and then check the machine if they have the capacity to run it, if it's best suited for running the job. And if it does, it's going to pull down the container image, right, and then launch the container for you. Very, very similar processing idea behind the scenes. Kubernetes was heavily influenced by our experiences in terms of managing containers from the past as well. So it's best of breed at the moment. And this is a very quick view of the config file that you can write. Okay. So very similar. Rather than a binary file, you specify the image that you want to run. And you can specify the resource limits, memory and CPU. You can also mount disks as well. And you can specify the port. And then you can, of course, specify the number of instances you want to run. So rather than talking about it, maybe I'll just jump into the demo as well. And I have about 10 minutes or so for that. So here I have the application I just built. Okay, I'm going to go back to that. And first, I need to be able to push this to a repository. So to do that, usually you do a Docker tag and then hello world. And then if you push it to like Docker Hub, you have some kind of special syntax for that, right? So if I were to push it to my own Docker Hub, I'll do Stalinism at / maybe hello world, okay? But what you can also do is to push it to a private repository. So like in Google Cloud, we actually have a private container registry that you can push your private images to. And it's really easy to use. So you can just tag it with, let me see here, config list. So I need to know the project name that I need to push to. And I can do docker tag -f hello world gcr.io. Oh. And hello world, okay? But this is only tagging it within my computer. And then I can just push it to the private registry. So I can do gcloud docker push. And the string for the image name. Oh, sorry. Docker. Oh, yeah, that's one too many. Okay. So that should send my Docker image from my machine to the cloud. Oh, that's really quick. Okay. And then what do? Once you have the image in the repository, you can just declare the desired state of this application. You can do that from the description file, like the YAML file or a JSON file, to declare how you want to run this, or you can just run it directly from the command line. So what I like to do is to do the run command, and to show you how that works, I like to go to here, and I have this little visualization tool that is not running because I killed it. Okay, here we go. So I have this little visualization tool that helps me to kind of show you what it looks like within the Kubernetes cluster. So my cluster right now has 4 nodes, and these are running in Google Cloud Platform, and it's running as Google Container Engine. It's a managed service for you. So you don't have to manually install Kubernetes at all. You can just say how many nodes you want in your cluster, and Google Container Engine can they just spin up and pre-configure everything for you, and then you can just use the command line to deploy your application. It's one of the easiest way to try out Kubernetes as well. So what I can do is to run it. So I lost the command line, which is great, so I have to do this by hand. So I'm going to kubectl run hello world. That's the name of the application. I can name this whatever I want. It's like an alias I can manage within Kubernetes. And then I can say the image is equal to the image that I just created. Here we go. Okay. And then I can say how many instances of this I want. I'm just going to, by default, it's going to start 1. And I'm going to put some labels on it. So everything in Kubernetes has labels, okay? And labels are something that you can just create yourself. The name and value, you can create whatever you want. And it's a really easy way for you to find out what's actually running in your environment. So you can actually select by labels. So you can figure out which pods are running or which containers are running based on selecting the labels. So I can do something like conference is equal to JFocus, and the app is hello world. And I need to visualize this. I'm going to say visualize is equal to true. Yeah, maybe that will work. OK. So the visualizer is actually pulling this data from the API from Kubernetes of the current state. And very quickly, you can see that Kubernetes has created two things for me. The box in the blue is called a replication controller. Okay? Replication controller kind of manages and oversees what we call pods. It actually just manages how many instances of something you want to run. And the replication controller is responsible to achieve the desired state of your system based on configuration. So in this case, I'm telling the replication controller that I need to have one instance of my Hello World application running, and the box in gray, that is the application that's running right now. Okay? And the box in gray is not just a container. Okay? Up until this point, I'm talking only about containers, but the box in gray is another concept in Kubernetes. It's called a pod. A pod is the atomic unit that Kubernetes can manage. It's not a container, but it's a pod. Now, what is a pod? A pod is actually a group of containers that have to live and die together, that have to share resources together. Okay? Now, you may think, what can be in a pod? Well, some people can say, well, you need the front end and the MySQL database. That should be in a pod. But that's not the case. That is not the case, right? Because you want to separate those into separate layers. So you would have a pod for the application, another pod for MySQL service. And they'll be different, and they could be managed differently by different replication controllers. What you can put in the same pod, however, are things that are really, really closely related together. For example, if your application is exporting some metrics or is outputting some log, then maybe you need to run the log collector or the metrics collector in the same pod, within the same namespace, so that you can access your application very easily. So in a pod, you can have multiple containers. In most cases, you're just going to have one container inside the pod. Okay, so in my case, there's just one container running inside it. Now, what if I need to access it? If I need to access it, I can just expose this as a service. So I can do something like kubectl expose the replication controller, hello world, and the port is 8080, and the target port is 8080 as well. I'm going to expose it to the outside world on port 8080, and then I want to create a type of load balancer. And that should create the box in green, which is a service. Okay? And the service is really just a load balancer. It's very similar in concept. The way that it's implemented depends on the provider that you're using. And basically, it will be able to route traffic from a stable IP address and route it to the different pods, the different instances that you have for your application. Okay? And the way that it's going to be able to route the traffic and being able to figure out which instances I need to route to is by using labels. So you can say hello world service only route traffic to pods to these containers with the labels of hello world or to the environment of production. You can actually use services to front your applications and expose different parts of it to the outside world if you want to. Or you can actually create an internal service which doesn't have an external IP address as well. So while this is spinning up, it's going to create an external load balancer for me in the cloud as well. So I'm going to wait for that. But in the meantime, I'm going to show you something else. So I'm going to go ahead and scale out my number of instances here. Okay. So I can just tell Kubernetes to scale hello world. I can tell the replication controller that rather than just having one instance, I need maybe 3. So I just do replicas is equal to 3. And that should actually just spin up 2 more instances for me. Okay, it's very, very cool. And if you look carefully, these instances in parentheses, that's actually the node that the application is running on. So I never tell Kubernetes where to run this. It just figures it out for me. And it's really smart enough to kind of just figure out the best place to run it. As you can see, they're running on different machines. And what happens if you actually, something actually happens to it and something dies, right? So I can get pods. And I can kill one of these things. So kubectl delete pod, like that. Now watch very carefully. So it's going to recognize that something got deleted, and very quickly, it happens so fast. Very quickly, it already is spinning up another machine, another instance for me. So, and there you go. So even though I deleted something, it just spins up immediately for me another instance. And the thing I just deleted is gone. So dbu89 is gone from this list of pods that I have. Okay. Another really, really cool thing is that you can actually do a rolling update. So what happens if I need to update my service here? Okay, so I'm just gonna do a quick going back here. So I'm gonna go ahead and just change this, right? So I can actually just change this, and maybe it's x multiplied by y and plus 1. That's not a good multiplication. Right, so you can do that. And then you can build it, and then you can tag it. Come on. Yep, and then you can tag it, and you can push it, and tag it. And when you tag it, you can tag it with a different tag name. So I can say v2 here, and then I can just push the v2 to the cloud as well. And then once that's done, what I can use is a kubectl. There's a command line called rolling update. Okay. And what I can do is, let me see here, rolling update. I can say the name of the replication controller I want to replace with the image I want to replace as well. Okay. So for example, I can do this command line right here. So I can do rolling update, hello world. And the image is the v2 image. So I can just copy and paste that image name. And then I can specify the rolling update period, but I'm just gonna do this very quickly right now. Okay. So what this is going to do, if it works, is it's going to create another replication controller for me, like that. And then slowly take away an existing version of the application and then introduce new versions into the mix. And all at the same time, the service, the load balancer in the front, is completely aware of what's actually accessible and what is not, and people who are using the service will not be affected. Okay, so that's really, really cool to do. And oh yeah, I have the proxy running again, but I should be able to just hit it right now. Okay, so that's really what Kubernetes can do. Really, really awesome stuff. Really easy to do. I'm gonna jump in because I don't have too much time left. I'm gonna jump in into the next part of the demo, which is gonna be pretty awesome. So I was in conferences. I was in many different conferences, and I ran into friend Arjun from Quintor at JFall. So I'd like to invite Arjun up to the stage and tell you a little bit more about the things that he has done. So Arjun, please come up.
Yeah, welcome.
Yeah, thank you.
Well, welcome here. I ran into Ray at JFall last year, and we had built a Raspberry Pi cluster, and we got a chat. And let's introduce myself first. I'm Arjen Rassink. I'm a Java developer, basically, and also an architect, a team lead at Quintor. Quintor is a Dutch company that's mainly focused in software development, and one of the things I find very important is that it's not about writing code, but it's about delivering systems that actually get used and work really well for your end customers. So you always have to know your applications, what it's running on, and all the technology that is involved, and also be part of the operational part. So who didn't hear about DevOps? No hands, really good. One. Oh, DevOps, yeah. You have to check that out, because everybody is responsible for their software running in production. And what we saw at Quintor is about 2 years ago that we saw the trend of microservices and so on, and that's really changing the game in which we are developing software. Ray already mentioned we're splitting up our applications in more and more separately running processes, and when we do that, we're running more processes, but to gain the same reliable service we are previously providing, we need to run more and more instances. So it's an exponential growth in number of processes we're running, and as you're also responsible for operations, you have a new challenge. And what we see is that Docker and cluster technology like Kubernetes is really helping us to gain that control again.
So Arjun and his team actually built this Raspberry Pi cluster. I ran into it, and I was like, hey, why don't you try putting on Kubernetes on it? Because it will be really fun to do, and we can run some Java services on it, which we're doing today. And then we can play real chaos monkeys. Meaning, I've been to data centers before. I just want to pull the plug on something. And you actually do this here. So Arjun, what is actually on here?
Yeah. So what we've got here is 4 Raspberry Pi 2s. So there's quad-core processors, 1 gig of memory, 16 gig of SD card storage, a small network switch. It's a really simple one, and a USB power supply, and that's all. And a nice casing. It's a Mod Pi casing. So if you want to build it yourself, I have written a blog about it. Here's the blog, Kubernetes IO. Go there. There are 2 blogs, one on the hardware. So anyone having its birthday soon. It costs about 3,000 krones.
We posted the blog just before Christmas, so I know we made many people happy. And that is actually my cluster. So I wasn't able to get the exact parts, and it doesn't look nearly as good as that one. So just saying, to get whatever that's on the
and then also there's a blog on the software. I use Hyperion as a base image. Really great starting point when you want to do Docker. Running Docker containers on Raspberry Pi, one image, put it on your SD card, and off you go. So really great. The team is doing a really great job. Got Kubernetes running on that in a Docker container, of course. And Kubernetes has 2 things they need: etcd. Etcd is the storage of the state of your Docker Kubernetes cluster. It's a desired state configuration that's stored in there, and we need Flannel. Normally, Docker containers over different nodes, over different machines, can't communicate directly with each other. Kubernetes does need that. So Flannel is a network bridge underneath the Docker process that enables us to do overlaying networking, so creating a virtual network over the cluster. So every container can call its colleague container no matter where it's located in the cluster. It's really powerful.
So what we have running here, again, I'm going to use my visualization tool here. So you can see that we have 4 nodes, and every one of them has a different IP address. The 0.0.1, that's actually the master node on the very top. And then we have 3 other nodes that's also running some workload. And we have deployed another Spring Boot application, this Java microservice that I wrote before. So you can find a base Java image to run on Raspberry Pi as well. And Java is, of course, portable, so it just runs everywhere. And I can just hit the service URL, and that's kind of the response I'm getting. Now, on this cluster, what I can also do is everything that I was showing you before, so I can actually scale RC, hello world. Replicas is equal to 4, and that's going to scale out the number of these instances I have on the Raspberry Pi cluster. So now you can see that we have 4 instances running, and again, in the gray boxes, these are the pods. These are the actual application instances running, and they're again in the parentheses. You can actually see which node they are running on. So we have one that's running on 237, one that's running on the master, one that's running on 214, and so on and so forth. Now, when Arjun had this before, the IP addresses were actually like 1, 2, 3, 4, 5. So we can actually tell which one's which. But these are assigned by DHCP, so we have absolutely no idea which IP address is corresponding to which node, except for the master node. But that's the fun, because you probably don't know that in your data center anyways. But then what we can do is if there's any volunteer who want to try it and break our cluster by pulling on the cables. Anyone? Come on, there's got to be One person. All right. Come on up. Let's see if you can get through. Yeah. All right. Let's give this gentleman a hand. Great. Thank you. I really appreciate it. Okay. So come on up, and why don't you come around here, on this side. All right. What's your name? Richard. Very nice to meet you. Ray.
Hey, be gentle with it, huh?
So. You win a chocolate as well.
Yeah.
So we have 4 nodes here. Just remember, don't pull the first one. Yeah.
All right.
Yeah, because that connects to my machine, and if that's gone, you cannot see anything.
Yeah.
Pull the network
One of these 3.
Let's do the network first.
Yeah.
And we have absolutely no. Wait, hold on a second. We have absolutely no idea what's going to happen, and we don't know which node this is corresponding to because Arjun put this together. So there he goes. Wait, what?
I glued it.
Oh, there we go. Okay, all right. So hold on a second. Now watch. Kubernetes at this point is going to, do the node checks, right? It does it every 5 seconds or so. It's very configurable. But it doesn't fail the first check. It waits for like about 30 seconds or so. That's also configurable. And if it works, it's going to realize that the node has gone away in about 30 seconds or so.
Yeah. Worked yesterday.
It did work yesterday. What happened? And come on. Let me do a kubectl get nodes. Let me see. There we go.
Yeah.
There we go.
Yeah.
All right. And then Kubernetes is going to realize, wait a second, the pod that was there needs to be rescheduled.
Yeah.
Okay.
So a new one is there.
And it's terminating the other one. But so in Kubernetes, there's this graceful period. So it's going to wait for about 30 seconds or so for the pod to shut down gracefully. But in this case, the machine is gone. Yeah. So it's going to take about 30 seconds for kind of terminate that pod. So I think that will happen way too fast. Because as soon as the node was recognized to be down, it then starts another instance for you. Because your desired state is you want 4 instances, so it's able to just start another one for you. So what happens if you plug it back in?
Yeah.
So again, it's going to do that node check for every 5 seconds or so. Because we only pulled the network cable, so it should actually recognize the node to be healthy again very quickly. But I know yesterday there are some issues with the network, so we just have to wait and see. So while it's doing that, thank you very much, by the way. Yeah, thank you. All right.
Thank you.
Yeah, there we go. So I see what's walking back up. The node is being recognized as healthy.
Yeah.
And I can, again, to schedule work here. So I can do a scale 5, for example. Yeah. And because the node is healthy, it's now able to schedule the workload onto that node again. But that's a little bit too easy. Because these are stateless workloads, right? So there's no data.
So we have 2 minutes.
So we have 2 minutes. So I'm going to show you something in about 5 minutes or so. If you're willing to stay around, please do. Because I'm going to show you something with persistent data, right? Yeah. In Kubernetes, you can actually mount volumes. And these volumes can be a cloud volume, right? If you're in a cloud platform, it can be a cloud disk. If you're in your local, your own data center, it can be NFS, iSCSI, RDB, or a bunch of different technology is actually supported. So hopefully this works. we have NFS server running on that machine.
On the laptop?
That's exporting some directory, which we are going to use as a volume. It's exported on NFS. In Kubernetes, you can actually declare what volumes you can use by declaring one of these YAML files again, and just say, what type of storage it is, right? So I can say this storage can hold 1 GB of data. It's a read-write once, so you can just be mounted by one pod, for example, for read-write. And then how do you actually connect to it? In this case, we're just gonna use NFS, so we're connecting to the server on that specific node, on that specific path, okay? And then for you to use it, you have to claim the ownership of it, right? Because in Kubernetes, the storage is a bunch of resources that anybody can take and use. So you have to take ownership of that. And to do that, you can make a persistent volume claim, which says, okay, here's the request. I need 1 GB of storage, read-write once, and it's going to go out and find it for you, okay? And so if I do a get PVC, I can see that this MySQL claim, this ownership to the storage, is bound to the actual NFS mount, okay? And then what I can do is in MySQL, again, I'm gonna do a RC here. in the end, I can say, all right, this MySQL server needs the volume, so I need to mount a volume into the directory where MySQL stores data, which is varlib MySQL. And then the name of the claim, that ownership, that ticket to access the storage. Okay. And then what I can do is to create and run this. So I'm going to do kubectl create-f MySQL-rc, and that should actually run MySQL instance here. Okay. So oh, that's no good. That's actually running on the master node, so that's not. I don't want to do that. So what I'm going to do is to get pods, and I'm going to delete it. Okay.
Yeah.
And hopefully it's going to be rescheduled somewhere else. Okay.
Yeah, there it goes.
Okay. So it got rescheduled to 214. Okay. And what that means is the volume is actually mounted on that node on 214. And what I can do, a very quick demo of that, is to do MySQL u root p host is RPI master, I think. What's the password? It's your password. That's the password. Okay, so I'm inside of this MySQL, and I can show databases. There's app. I can do a show tables. There's nothing. How many people remember how to create a table in SQL? Yeah, create table. Hello. Yeah. Okay. Greeting. Yeah. Varchar 30, something like that. Semicolon. Wait, what? No, yeah. There you go. All right. And then how many people actually remember how to insert? So few people. Wait, what is going on here? Do people just use Hibernate and JPA? Insert into greeting, right? Oh yeah, of course, the table name. I always forget.
Only the NSA stores all that.
And then hello, JFocus, right? JFocus. And I can select from here. Now this is difficult, so I'm gonna just exit out of it. Live demo with real devices, yeah. So now what we're going to do is we're gonna kill the node. So since he's still there, so why don't you come back here? You gotta kill my MySQL server this time. Now this is different. This is difficult to do.
But first we need to know
which
which node it is.
Yeah. So
we only have a randomly.
So it's on 214, right? So
214,
anyone used ARP command before? This is a little known command line. Yeah. You should know about this. Yeah. So with ARP, I can actually see that 214 is on node number 1.
Node number 1. Okay. So.
No, wait.
Yeah. Now we can't pull
that
the
one,
power
one.
cable.
Yeah,
so
you can try the power.
that one, yeah.
Is that the one? Are you sure?
Yeah,
Okay.
we'll see.
Yeah.
Pull it. Yeah.
All right. So again, we're gonna wait for 30 seconds or so, and then I will show you what happens to the MySQL server, and then we're off to launch. Okay, so this is the most difficult part of the demo because I never know if it's going to work. And if it doesn't, it's lunchtime, so we'll just walk away.
Yeah.
Slowly to the next room and cry. So come on, so it's going to recognize this node being down pretty soon. There we go. And very quickly, again, watch for the visualization. There you go. Yeah. So it's terminating the MySQL instance that's on the dead node, and then it's going to start another one on another node, which is the 237. 237 is what? This one. So I'm going to SSH into it. So I'm going to do a very quick sanity check. If it lets me SSH, okay, there we go. Yeah. Scary demos. Okay, so first thing I'm going to check is whether it has MySQL. It does. Perfect. And then let me check if there's a mount. Sure. Mount, sorry, grep, mount. As you can see, I'm very nervous right now. Okay, so there's the mount, right? So the mount actually got transferred to this machine. And then I can actually see what's inside of this mount. Data. That's a good start. Okay. Yeah. And then the ultimate test for me is to see if there's data in there. So again, I'm gonna go through RPI master. Now I'm not cheating here. I'm not running MySQL on the master node here. This is actually routing the traffic to the instance here. Okay.
It's a service.
Yeah, it's a service, so it's routing the traffic. Your password. Yeah, that worked. Use app. That's good. Show tables. Yeah. Are you ready for this? Select star. So normally you wouldn't want to do that because you want to make sure your MySQL server shuts down gracefully, writes the data, synchronizes it to the disk and stuff like that. Right, but this is just a demo, and let's see if it's there. And are you ready? Yeah, I'm now. So select start from hello, and there it is.
Dude.
Yeah, thank you. And thank you again. Yeah, so that's what Kubernetes can do for you.
So,
yeah. So that's all I have, and thank you for staying a little late with me.
Yeah.
And if you have any questions about Kubernetes, feel free to come up and ask the questions.
or Raspberry Pi.
And Raspberry Pi, ask Arjun and check out his blog. And thank you very much. Yes.